In this topic, we're going to find the trig ratios given a right triangle. So let's say we're going to do a very thorough example. So let's say in this example, they give you a picture of a right triangle. And again, this is not drawn to scale, it's just a sketch. It's probably what you would write down in your scratch paper and your notes when you're doing problems in ALEC. So they're marking the reference angle with the letter theta. And let's say this side is 15 units long and this side is 8 units long. Again, not a very good picture as far as drawn to scale. It doesn't look like that's really 15 and that's 8, but let's assume it is. And they don't label this other side for you. And let's say they want you to find the following trig ratios. They're saying find cosecant theta, cotangent theta, and let's do the secant theta. So first off, if this is your first video after watching just regular sine, cosine, tangent, you might say, I don't even know what in the world cosecant is or what CSE is. All this says is the cosecant. That's how you read that. And really, this is the reciprocal of the sine function. So this is the same as 1 over the sine of theta, which really when it comes down to it, if you remember, sine is like so, right? It's the opposite over the hypotenuse. What that really means here is that it's the exact reciprocal of opposite over hypotenuse. This would be the hypotenuse over the opposite. So cosecant just means it's the hypotenuse over opposite. It's the reciprocal of sine. Cotangent, so again, this one is red, cotangent, that is the same as the reciprocal of tangent, which is 1 over the tangent of theta, which, if you remember tangent of theta, that is TOA. Tangent's supposed to be opposite over adjacent. All that means is cotangent is the reciprocal. It's not opposite over adjacent, it's adjacent over opposite. And then secant is just 1 over the cosine of theta. So it's the reciprocal of cosine. And if you remember, cosine is CAH. That meant adjacent over hypotenuse. So we just flip that fraction and it's the hypotenuse over the adjacent. So those are the other 3 trig functions besides, you know, your SO, your KA, your TOA, right? They each have a reciprocal trig function. So let's see if we can find these. Now, if I wanted to first start with finding the cosecant of theta, I might first tell myself, okay, cosecant, you need to remember that is the reciprocal of sine. So that means it's going to be hypotenuse over the opposite as defined here. So you might say, okay, great. I'm going to do the hypotenuse side over the opposite side. Now, in the triangle that I'm given, if this is my reference angle, and here's the right angle, this is my hypotenuse. The opposite is over here, and the adjacent is here. And so I know only the opposite side of 15, so that's going to be a 15 in the bottom, but hypotenuse I don't know. Well, it's not a big deal. If you have a right triangle and you know 2 out of the 3 sides, you can use Pythagorean Theorem to find that last side. So, quick side note, you might need to do the Pythagorean Theorem, which is the following theorem that you guys have probably used before. I like, a lot of teachers will do like a squared, b squared, and c squared. Any right triangle just has a leg, hypotenuse, right? In general, Pythagorean theorem is just leg squared plus leg squared equals hypotenuse squared. That's probably the best thing to remember to me. Instead of a squared plus b squared equals c squared, some teachers use leg squared plus leg squared equals the hypotenuse squared. So for this problem, I have the following equation. I can say, well, one leg is 8, so I'm going to square that, plus another leg is 15, so I'm going to square that, and that will be equal to my hypotenuse squared. So 8 squared is 64, 15 squared is 225. That's going to be equal to my hypotenuse squared. So if I add 64 and 225, that'd be 289 as my hypotenuse squared. And so if I square root, that's going to be my hypotenuse. The hypotenuse is the square root of 289, and that's what I can use. So I have the square root of 289, and I'm going to just double check that that's not a perfect square. I probably should know that. I don't recognize it, but let's make sure that we can't just square root that. Square root 289. And it is. I should know that. Embarrassed, Mr. Schultes. It's a 17. So that's 17, really. So I have an 8, 15, 17 right triangle. So now we can answer all the questions. We have our hypotenuse is 17. So cosecant of theta is just 17 over 15. Let me see if I can sneak in cotangent. If I had to find the cotangent of theta, remember that is just the adjacent over the opposite. Adjacent over opposite. Adjacent is A. Opposite is 15. So for cotangent, it would be 8 over 15. If I had to find the secant of theta, that would be hypotenuse over adjacent. So hypotenuse, 17 over the adjacent side, 8. And of course, let's say Alex were to ask you for the sine of theta. Well, you'd know hopefully that that's the opposite over hypotenuse, and you can do that too. You can do opposite, 15, over hypotenuse, 17. I mean, you can answer everything. Now, if you have all three sides, it's not a big deal. You could do cosine. That's adjacent over hypotenuse. Adjacent would be 8 over the hypotenuse, 17. And let's just finish this off and be perfect. The tangent of theta would be the opposite over the adjacent, which would be opposite 15 over adjacent 8. Notice, by the way, like cotangent and tangent, they're just reciprocals, right? 8 over 15, 15 over 8. Sine of theta compared to cosecant, they're just reciprocals, 17 over 15 and 15 over 17. And then secant compared to cosine, those are also reciprocals, 17 over 8 and 8 over 17. So I guess the trick is knowing your reciprocal trig functions, cosecant, cotangent, secant, and then also being able to use that Pythagorean theorem to find a missing side length of your right triangle as needed so that you can complete all your ratios. Hope this helps you guys. Thanks for watching.